Dear civil engineers, now we are going to design a pile cap using software, and using SAFE software from Etabs data, Etabs analysis data. Now I'll design a pile cap below that 4 columns. Okay, so below that 4 columns I will design a pile cap, and another pile cap I need here below that 2 columns. So in this lecture I'm just going to show that how we'll design a pile cap below 4 columns. Right now, to do that, first of all I'll go to our Etabs analysis. Here already I have analyzed our model, and from here I'll just go. Then I have created a combination with all gravity load. Okay, so I'll design that only for gravity load. If I show you, go define, then load combination, and here I have created a combination with all types of dead load with a scale of factor 1. Okay, that means 1 gravity load actually. So okay, and another thing I have done here, number of footing. So how I have created that, combination, if I just go here, modify, just see there have a scale factor 6.480 into 10 to the power minus 3. Okay, so how I have done that? Actually I have created that scale factor using the capacity of pile. Okay, how much capacity of a pile? First of all, I have calculated capacity of piles. So here if I show you our capacity, I have considered 85 feet pile with 20-inch diameter, and this is from soil test report, and this is 70.93 ton. So if I just convert that value here, just see 70 into 4.44 something. Okay, so sorry, I have to convert that from ton to keep, as our wall data, we have analyzed with FPS method, FPS unit. Now I'll go here and 70 into 2.204. Here this is our value in keep. Okay, so this is our value in keep from ton to keep. And also if we convert that, or also if we want to convert that data, we can do that easily. Now if I just show you another thing, here also I have convert from ton to keep 154.32. okay, 154.32. this is the capacity of one pile with 85 feet long and 20-inch diameter. This is the capacity of one pile. So how much number of pile required? If we divided the total load on that pile by one pile capacity, then we'll found our capacity factor. So here just see 1 divided by that one pile capacity, and if we just like that, suppose close, and if I just go here, and from here just GL, just see what is the load from our building to that column, base reaction 314. So this is 314 divided by 154. That means we record 2.0 389 pile, right? So after analysis it can be changed. So this way I have just done that. So this is nothing but 314 into 1 divided by 154. Just I have done that thing in our load combination to create that NF. Just see here, number of footing. I have created that combination by applying that factor in our load combination. So apply, just okay. Now see here, we can just found a approximate number of pile. Okay, this is not exact, we'll find out that value after analyzing. So this is a approximate value, so that we can found a idea from here. Now I'll go for analysis. Okay, so here now if I estimate how much, now how number of pile we require, say 1.5, 1.5, 1.33, 1.33. That means if we provide 6 pile, maybe it will be okay, right? Maybe it will be okay. So to do that, what I'll do, I'll just go here, then from combo I'll take that value. Now I will design a pile cap below that 4 column. To do that, first of all, what we have to do, actually we need to identify that 4 point, okay, in AutoCAD. So what is the distance of that 4 point? I mean, we have to find out our pile cap size first of all. So to do that, I'll just go here, draw, then I have to unlock first. Better I take a screenshot first of all. Okay, done. Now unlock and draw dimension line. So from here to here it's 8 feet, and in that direction it's 6.333 feet. Okay, 6.333 feet, and in that direction it's 8 feet. Now in AutoCAD, otherwise here we can do that. So first of all, I'll take some point from that center to that column center to that column center to here and here. Okay, so this is the center point. I'll select all of that, copy, I'll take them another place. Done. So this is the position of our column. That 4 corner represent our column position, right? Now we have to find out another things, that is our pile cap size. So we have to take decision where we'll place our pile. So if I just see the dimension from here, 6 feet and 4 inch, and in that direction 6 feet 10 inch. So from one pile to another pile, our spacing from center to center spacing of pile will be 3D or 2.5D. So I will consider here 2.5D. Okay, 2.5D means diameter of pile, that means 20 inch, that means 50. And another thing we have to do here, so one pile to another pile distance will be 50 inch, right? Now in that direction, what is the value of 50 inch means divided by 12? That means 4.16 inch from the center to center value. So here in middle position we'll provide 2 pile and 4 pile in 4 corner. I'll just close that. Now first of all, I'll place 2 pile here, 10 inch here, copy. Randomly I will place 1 pile, suppose here, because in that column and that column we have more load. For that, this is our center. Okay, this is our center, and from center here from here, okay, I'll do another thing simply. From that center to another pile center we'll consider 50 inch. So copy. So from that center to that direction I'll open ortho mode. Then in that direction, how much it will be? 50 inch. So this will be, that will be our pile. Now if I take another simple thing here, I'll stop our ortho mode and here. So this is the center of our that arrangement, and above, little bit above that center we'll place our pile gap. So from here, what is the distance actually? 3 feet 2 inch. Okay, 3 feet and 2 inch, right? 3 feet and 2 inch. So from that point I will go above for 6 inch more. So I'll take a line, and from that center I'll go for 6 inch. Done. Now I'll copy that, okay, and from here Ctrl C, I'll take another line here to find out the center point, center of 2 pile. Then I'll copy that on and that on. Then CO, copy, enter, and specify the base point. So here will be, that will be our base point, and after that I'll place our 2 pile here. You see, this is a 2 pile. Now where our another pile will be? Our another pile will be 50 feet away from that pile. Minimum 50 if not feet, 50 inch. Okay, so it's done. Now we can do that simply. From that point I will go in that direction for 50 inch. Sorry, I have provided feet, not feet, inch line. From here 50, and okay, in that direction that will be 50, or in that direction that will be almost 50. Okay, and they have another way to do that. I'll close that, and I'll take a line here, and in that direction here, and from that point to that point. So suppose our one pile is here and our another pile will be here. Okay, another pile will be here. So in this way we can do that by applying simple Pythagoras উপপাদ্য, equation of Pythagoras উপপাদ্য. Otherwise we'll go for another trip. Actually, this is totally depend on you that how we'll do that. They have no I mean, they have no this is not a big issue. Actually, you can do that anyway, but we have to do that perfectly to maintain our clear spacing. Now here, I'll just go from that point to in that direction for 15 inch. Suppose from that point to in that direction, okay, for 15 inch. So this is our 15 inch distance. Clear? So here we can place our column actually. Now to place our column perfectly, I mean pile, I'll just go in that direction. I'll just go in that direction. Okay, done. Actually, I just want to place our pile in an exact position. So here from that pile, I'll just go here and I'll just go here. Now just here we'll place our pile. Okay, so to do that, otherwise we can move little bit here. It's totally depend on you. It's totally depend on you actually. Now okay, go little bit here in that direction. Okay, for 50 inch. Yeah, 50 inch. So here are 15. Now I'll close, I mean I'll delete everything, and here I'll place our first pile, right? So copy one of them, copy the center point and place your on pile here, right? Now delete all of them, simple. And they have something, delete them, and also delete them. Now I'll close that one, and also just go to in that direction. Okay, and similarly we can take a mirror of that. So I'll copy, select, then mi mirror. After that, from that point to that point. No, so here are another pipe. Done. After that we need another pile below, I mean here and here, for that point column and that point column. I'll close them. Now I'll just check what is the distance here actually. So from that center to here, 3 feet and 11 inch. That means this is not sufficient, and that was how much? 4 feet and 2 inch. So in that direction, okay, with respect to that point, in that direction we have to go for we have to go for 4 feet and 2 inch, right? 4 feet and 2 inch. So here randomly I'll take a point for 4 feet and 2 inch. Okay, for directly 50 inch. Sorry, my ortho mode was 1, and I'll take a line, not a distance. That was the issue actually. Stop ortho mode and take here 3 feet 11 inch, and we need more 4 feet 2 inch here. Okay, just take a line from that, take a line from that center to here actually. So if we take or another pile cap here or little bit away, then it will be okay actually. So I'll delete, and by using line go. So how much here? That is 7 feet 1 inch, and if I just go little bit, then 7 feet 6 inch. So this is 7 feet 6 inch done. Similarly, now I'll just go in that direction with respect to that one. I'll draw another point. So we have found our all pile location, right? I'll delete that on. Sorry, I need that point also. Now I'll place pile CO here. Stop ortho mode. Here we need one pile. Here we need another pile. Just done. We have placed our all pile actually, right? All pile. Now if I take a polyline and we'll go through our center point of that pile here, here, and also here. Done. So when it's done, now we need our each distance. So what will be our each distance actually? I'll consider here 20 inch, but actually it's required 1.5D. So I'll consider 20 inch. That means I'll take ortho offset 20, then enter and take a distance. Done. This is our actually, this is our pile cap. And here in that 4 point, we have to place our column. So I'll copy that column, that column, that column, and that column, and CO copy with respect to any base point. See, it's sorry. Now again I'll go here, select that on, here, that on, and that on. Here, copy, and here. So it's done actually, right? Now we can delete that. No need that. So finally our pile cap are ready. Now I'll take distance, we'll draw that in our software. So actually it's totally depend on you that how we'll do that. There are no exact method or anything actually. So okay, done. First of all I will take that distance. I mean now we'll draw that pile cap. Here I'll go to software, I'll go for new model. Okay, and here now go here and US customary done. Yeah, this is okay also. And for our design code, I'll use 31808 as this code is similar to our country code. Then I'll go okay. And so I need grid in X direction 2 grid, and in Y direction I need 2 grid. And for another I will I'll take point actually. So in AutoCAD, what is the distance actually? That is 12 feet and 3.94 inch in X direction. 12 feet and 3.94. Enter. So this is our total value, and spacing in Y direction here 10 feet and 9.89 inch. Actually we can arrange that actually. Okay, actually we can round that value 12 feet and 4 inch, and here 10 feet and 9.89 inch. We can do that, but I think no need. So here 10 feet and 9.89, 10 feet and 9.89, enter. So this is done. And number of history, how much number of history you want to take, actually no need to follow that value. So grid only, then press OK. So this is your points, right? Now I'll go here, define, then materials property. We'll go for materials property. Now here this is 4000 psi, but we need 3000 psi concrete. I'll just go modify, and here I'll give 3000. Everything will be okay. Just here we have to change our that value. So what will be that value? 5700 into root over fc prime. So 3000 0.5 is done. Okay, and everything is okay. I'll just go here and change that value from f prime c 100 psi, and here 3000 psi, and then okay, then okay, it's done. And we'll change also for our grade steel, so that will be everything will be okay here, and just only change will here, that will be 72500. Actually, as per your requirement, you will provide that value, then copy that. I'll copy that value, and this value will be 1.25 into fy. It's done. And that value will be 1.1 of that value, 1.1 into that value, then enter, and that will be 1.1 of that value, 1.1 into that value. Done. Then okay, then okay, then okay. After that we'll go define, then section properties, then we just only need slab section. So first of all, I'll delete that one. Now I'll go add new properties. From here, first of all, we need pile cap. That means I'll consider that is as a mat, sorry, PILE, pile cap. Pile cap 3000 done. Everything is okay. Just here that will be mat. Okay, and I'll consider for 24 inch for first time. If need to change, I'll change that later. So that done. Again I'll delete that one. Now add copy of property. Now I'll take data for pile. Okay, so for pile that will also be mat, and it will be also same as 24 inch. Okay, after that I'll take add new properties, then column. So that will be column col column, and that will be is column stiff. That will be stiff. Then that will be also 24 inch. Everything will be same, every thickness will be same. Then okay, now this is done. After that we'll go here, and we need to provide our spring, point spring. I mean, for pile capacity, to provide pile capacity we need to provide that value. Before that I'll just go here, load pattern, and only I'll provide all load as a dead load. All load as a dead load, as I'm considering, I mean they have several combination, but I'm considering dead load plus live load. But from Etabs I'm considering I have created a combo with all dead load and live load. So here only I'll provide that value as a dead load. I'll delete that one. Then okay, and from combination or from load case, here dead load done. And from our load combo I'll take only one combo, so combo 1 and dead load 1, done. Then okay, done. So everything is okay actually. Now I'll draw our column, pile cap and pile arrangement. So to do that, first of all, I'll just go here, draw. I'll use that option, and here I'll select pile cap, and from that point to that point I'll click. Just see, this is our pile cap. After that, I'll take the point of our pile. First of all, I'll take point of our pile, so where I'll just go here, and now, so what is the distance actually? Sorry, here linear. So from center of pile to in that direction, this is 1 feet 8 inch, and from center to here, that is 1 feet 8 inch. That means from that corner, every pointer inside 1 feet and 8 inch, that means 20 inch. So I'll just go here. So here in x direction 20 and y direction minus 20. So I'll take draw joint object, and here in x direction 20 inch and y direction minus 20 inch, enter, then click here. After that, actually this are not showing. If we go just refresh Windows, just see it's showing. Now here every value are here the minus, just click here, and for that point x will be plus and also y will be plus. Here again here, so here y will be plus but x will be minus. It's very simple. Done. Then go for define view, then refresh Windows. Done. This is a 4 point. Now we'll find out our another 2 point. So here this is our another 2 point. Simply I'll take linear from that center to that distance 4 feet and 0.97, and here 4 feet, 5 feet and 9.14, then 48.997 in that direction, 48.97. okay, and here 69.14. okay, so 48.97 first in x direction, 48.97, and in y direction 60.8. how much that was? Sorry, it's 60. So no, this is not correct actually. I'll go here. Actually this is 0.97 inch actually. Okay, it's done actually. Yeah, then 5 into 12, that means 69.14. 69.14. It's done. 69.14. 69.14. 4869. When it's done, now I'll take a point here, and from that side just only value of x will be minus, then click here, and from here view, refresh Windows, just see here one point, here another point. Now I can place our I can place our pile cap. So I just go here, draw quick around, then from here this is not rectangular, that will be circular, and that will be piles. So what is the diameter? It is 20 inch. So here click here, and that point and that point. Just see, we have done creating our pile cap and pile cap. Now we have to provide our column. To do that, I'll just go here. Okay, I'll just go here. Now I will just delete that value. I'll delete all of that. Okay, now I'll go again linear. So from that center to in that direction, what is that? 2 feet and 4.75 inch, and from that point to in that direction, 2 feet and 8.97. okay, and for that one also I'll take, that will be same, and in that direction this is also same. So maybe for that 2 column this bulb also same. So what is the value? 2 feet and 8.9. that means 24 plus 8, 32.97 in X direction. Draw, then draw joint object. 32 point, what was that? 32.97. And in Y, two feet, and that means 24 plus 4, 28.75 in Y direction. Maybe 75, yeah. So for that one I'll take a point first of all here, and for upper point that will be minus here, and for that one both will be minus here, and for here only X will be minus but Y will be plus. Done. Then if I just go here view, then refresh Windows, just see here, 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 and here. I found our 4 point actually. I'll just close. Now I'll draw our column. So first of all I have to see its direction. So all are in that direction. Okay, all are in that direction. What is the size of pile? Now we need to know that. So go linear, and from that point to that point, that is 1 feet and 10 inch. Okay, but here this is not a correct size. I'll just go or softer. And what was that grid system? That is B. Okay, from that plan, if I just go here, it's also available here actually. So that is C2 and C5. So if I just go here, C2 and C5, this is 12 and 12 inch and 18 inch, but we have to take that point because this is our this is the section below grade beam. This is 21 and 15 inch. So I'll just go here, I'll go to a softer, then I'll go to a quick boundary, then that will be rectangular, and that will be column, and dimension in X direction, that is maybe 21, right? And that was 15. I'll check that again. 21 into 15 inch. Done. 21 into 15. Now I'll click here, just see here, here, and here. Done. I'll close So we have completed all arrangement. Now we'll apply load here actually. So to do that, go here and go to that screenshot where we have recorded our load. So for that two file, that was 232.5 and had 231. So for that file, I'll randomly consider 235. So both for both two, and for that two I'll take 210. Done. So 208. So for that 200, okay, 210, no problem. 235 for above and for below 210. So first of all, I'll select that point and that point. Now I'll go assign, then go for joint load, then force, and here in Z direction, okay, in force global Z direction, that will be for dead load, that will be 235. Keep. And what will be the dimension in X direction? That will be 21, same as our column dimension, and our dimension in Y direction, that is 15. Then apply. Okay, I'll little bit go in 3D view. Just see, we have done that value incorrectly. Okay, we have done that value incorrectly. So what we'll do actually, we'll just provide her minus, and again we'll click apply, and must remember it should be replace existing load. Then sorry, we have to select, I will use pre-select the 2 point, then apply. Just see, it's moved. Now I'll select that point and that point, everything will be same except our load. So that will be 210, then apply. Done. We have provided our also column load. After that, we need to provide now our that pile load. So I'll close that on. Now we'll provide our pile capacity. To do that, we need Excel, and I will provide that Excel sheet in our so here, this is a Excel sheet. I have downloaded that Excel sheet from internet. I will provide that link in, okay, I'll provide that link in description. Now here, actually this is not required, only I need that constant value. Okay, spring constant value, we need that spring constant value only. So what is, I mean, in what it's depend on, it's depend on modulus of elasticity, and it's depend on area and length of pile, and also depend on area of cross section of pile, that free value. So I'll just close. Okay, I'll close that on. So the modulus of elasticity will change automatically. I have considered 24. So that will be, if you consider 20 or 21, okay, 21, and after that 20 for 21, and length of our pile. So what is the length of our pile? That is 85 feet. That means 85 divided by 3.28. Done. Then 25.91 length of our pile, 25.9, okay, 25.91 means 26 meter. Then what we need actually, the utilization of that Excel sheet, already I have created video on it. so you can watch that. So here we have done that, modulus list of concrete, then length of pile, and just area of, area of cross section of the pile. So we have to find out that area. Okay, I can use Excel sheet very easily. So this is the diameter 20 inch. So what will be the area of that pile? The pile diameter equal to pi by 4. That means 3.1416 into 20 into 20. That means d into d divided by 4. Pi by 4 into d squared. So this is the area in millimeter square. So to now we'll move that data to meter square. Sorry. So actually, if we provide diameter of our pile, then it will also convert, it will also take its area automatically. Okay, so what we can do that, actually we can provide its diameter here. That means 20 divided by 20 25. So this is 0. Sorry, I will close. Then 20 inch we will convert that value to feet first. 12 divided 12 will provide that value in feet. This is the value in feet. Now again I'll divide it with 3.28 to convert it in feet. So 0.581. So it is 0.5 0.5081. Okay, 20 inch. Done. That means here 0.2 inches square. Now here our value in keep inch, right? Keep inch. Clear? That value is in keep inch. The spring constant are in keep inch. Okay. Now I'll just go to our software, and here I'll go define the spring property, then spring property, and new spring property. I'll just give its in SP spring properties, and in Y what will be the value of transitional Z linear. Okay, so that will be keep inch. Okay, we have to provide that value in keep inch, and I'll consider that is in only compression only. So from that software I'll take that value. This value are in keep inch. I'll paste this value and again copy and go to software. Simply paste it here. Done. We have done everything. Okay, now we'll go for analysis. I'll just run analysis. Before that we have to save our model. So file cap, I'll save it and wait for our analysis. After that we'll check some things. Okay, I'll close. Okay, I'll just go in our plan view. I'll close that on. Sorry, not 3D. I'll just go to our plan view. Actually this showing, actually nothing to worry for that actually. Okay, so first of all we have to check our maximum displacement here. We have to check that, and first of all I'll go here display. For here I'll just go punching shear design. Just see this value are in 2.1, 2.317, and this is also 3.120, 2.1, and for that 4 column. Okay, sorry, I have done a mistake. Actually. We have assigned our value, but we didn't provide here. So I'll select that point, that column, that file, and that file. After that, I'll go assign. Then I'll just go here, shell. Sorry, not shell. Joint, then spring, and provide that value of spring. Apply. Now it's okay. Again we'll go for analysis. Okay, close. Actually this is a graphical issue, nothing to worry about that. Okay, nothing to worry about that. So displacement for dead dot, here we can see our value are in here or here. This is in that point. I'll just directly I'll go for if we just go here for deform shape. From deform shape I'll just close that on. Then for dead dot I'll apply. Here we're seeing the deformation are very less. Again for combo we can that will be same for combo or for other things. G option, wire shadow, draw contour. Now I'll go for punching value. Here display, then show punching shear. So just see now it's okay. 97 and 8 or every point are okay actually, right? For punching shear design, see with 24-inch pile gap every point are okay. Now I'll go here, sorry, go display, and from here actually or from here for dead dot with jet, apply. We can see our applied force on our pile. Okay, this is 146, that is 154, that is 151, that is 151, 152 and 152. Now what is the capacity of our pile? And this is the applied force on our pile actually. So what is the capacity of our pile? That was 54.32. that means it's done. Okay, our pile capacity, with respect to our capacity, our pile are okay. Applied force on our pile are also okay, right? We just see here, this is also okay. 52, 52, there's no value which are more than 54, that means it's okay. So in punching here it's also okay. So we are seeing that in every situation our pile gap is okay. Now I'll go for plan view and I'll close it here, and I'll go for design. So for that I'll go to the show display, then show slab design. And if you're following me previously, then you know that I do not follow strip based design, I go for finite element based design. Okay, and impose minimum reinforcement. So for first of all, for direction on bottom bar, then I'll apply. See, this is our reinforcement arrangement. Okay, this is a reinforcement adjustment, and I'll just go with that value, typical uniform reinforcing. So I'll consider, I'll change our bar size, define the reinforcing bar size. I'll close, then unlock, because I'll not use these types of bar size. Actually we can change or that graphical representation here. From graphical presentation we can change it from here. Okay, minimum graphic font size, then anti, actually we can change that value from here, but no need to change. Actually I'll consider that value, assign. So I'll go define, then frame reinforcing, clear wall, add common bar size, then SI. Okay, then okay, again I'll go for analysis. Just see, close. If you go here for graphical representation, graphic font size 0.3, after that, okay, no need to do anything here actually. So I'll just go display, then show slab design, finite element, everything is okay. For direction 1 I'll go with that. And so bar size I'll consider 20 mm bar for top rebar, direction 1, so direction on or in that direction. In no need to worry about top now. So for bottom 20 mm with 8 inch, then apply. Just see, we need here little bit reinforcement, but this is very low, and here also this is very low, but at every place we need it any data. So if we go for 6 inch, just see, it's done. So what we can do, that we will provide 6 inch river in that direction. Okay, and for direction 2 bottom, so here we need little bit reinforcement. This we can neglect that, 0.03, we can neglect that. So also in that direction 6 inch. And now for direction 1, what we can do for direction 1, we'll use for top actually 16 mm and then 8 inch. With that also it's okay. And for top, actually how much reinforcement we require in top direction, this is very less. We're seeing that this is very less, right? Okay, so I'll go here, and if I go for 8 inch in direction 1 and for direction 2 8 inch, so here we need little bit reinforcement here for that, I mean below, I mean here and here. It's actually required here because they have no upward pressure, only, I mean they have no downward pressure, only upward pressure due to 2 pile cap, right? So we have to do that. And I'll go for, if we go for 6 inch, then also here we need little bit reinforcement. Okay, we need little bit reinforcement. And if we go with 20, then it's done. And here 0.04, that's little, 0.04, this little, 6 inch, this is 0.06, 0.05, 20 mm, 8 inch. Okay, done. So what I'll do actually, in top direction I will provide, in that direction, okay, in that direction I'll provide six inch. Okay, it's done actually. In bottom 20 mm 6 inch center to center spacing, and in top 16 mm 8 inch. Okay, 6 inch. So here actually when we provide 6 inch, then we need a little bit reinforcement here. So what we can do here, actually, we can go for in direction 2, in that direction actually. Okay, in that direction, in that direction, in that direction, we'll provide 20 mm in 8 inch, and in another direction, in direction top, we'll provide 16 mm in that direction. Done. 6 in below, we'll provide in both direction 6 inch, 6 inch. Okay, now close, done it, and save it. So in this way you can design a pile or pile cap. Actually it's looking very weird because of their graphical representation. I hope when they will update, they'll sort it. Okay, so thank you very much. Stay connected till next video.